Welcome to a new test and teardown video. Look what I got today. A very unique and beautiful frequency counter. It says frequency meter. How cool is that? It's from Racal SA520. And this one, I believe it's 4 digits. And it's with light bulbs that goes up and down, so that's kind of the indication in this unit. Really nice and special readout. I can't wait to see if it works. Look at the metal here. How is that possible to make it crack like that? So I definitely need a new handle. It's completely cracked, but it feels like it's kind of okay. But definitely you're gonna drop this unit if you trust this handle. That is not a trustworthy handle. The rear side here is completely full of information. Let's see if we can get all that. Initial check. Main set. Okay, we need to do that then. Set slide to test. Set frequency to check reading is 100. Okay, so there's an internal signal generator that you connect. I was hoping the test could light up all the bulbs at the same time. So that is how you test it. Operating on instruction, then slide to operate, and then it's frequency mode or okay. Reading. So you can of course overrun or overflow the display. So you just start here. So if you have if you have 123.456 kilohertz, then first you do this 1, 2, 3. Okay, so external batteries. Okay, so this is probably a battery. We need to consult the instruction manual. Don't you love this? What else? Period mode, simplified specification. Okay, so the input signal can be all the way from 70 millivolts to 90 volts. Whoa. Okay. I think we got it. Blah, 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 blah. There's not a lot more to say. But first we need to check this voltage selector. Ooh, there's a broken screw. It looks like a brass screw that is broken in there, so let's see if we can fix that as well. So how are we gonna open that? Yes, 2 screws here and 2 in there at the other end. Okay, let's have a look. And no big surprise in here. This unit is very tight packed. And that is definitely the crystal. It's a very beautiful glass crystal, and all the text is more or less handwritten. So we're probably going to lift up the boards. And how are they connected? Because I don't see any connectors. I was looking down here. I don't know if it's possible to see. There's a plastic bag covering some kind of stuff, so maybe somebody left something in there or a little note. So I need to have a little look in the bottom as well. Power supply voltage selector, so that is gonna change this to 240. Can we also, I don't know if that's gonna work, but I will set it to 240. And then we got a little bit of power supply parts down here, some rectifiers, signal diode, probably capacitors and all that kind of stuff. Nothing of big surprise, but I think I should be able to get the bottom off quite easily, so we can see what's going on in here. So I've chosen to disassemble this more or less completely, because I wanted to take this piece of metal here. I wanted to take this off and see if I can repair this screw. And then I also realized that the other is like super tight, so I think I should try and see if I can fix this as well. And then meanwhile we can have a little look at the internal parts here. Tolerance, temp, cal temp, all sorts of information on this crystal. I was looking at a date code, but I don't find that. And I need to be very careful what I'm doing here, because it's going to fall apart. As you can see here, those pieces of plastic, it's like really loose like this. It's only slides in like that, and now you can see all the 10 bulbs. They're only soldered in the PCB like that with super thin wires. And if you see here, we got spare bulbs. The little wires wound up in here, so the bulb sticks in there and it kind of stays in there. So I think you can solder new bulbs in from the outside, so you don't need to take the entire instrument to pieces. Ooh, I need to be careful what I'm doing here. I need to look much more. See, that is good. So I hope these gonna stay in, and all the super duper tightly stacked boards like this, it's there's actually no connectors or anything. They're just connected like this. So that's just the power and the trigger signals and stuff like that, and then counting signals probably is that one, right? And then there will be an input board, input amplifier or something like that. It's probably the first one, right? Yeah, so I'm just gonna go and fix the mechanical things and carefully look for anything that needs service. It looks a lot like somebody took out this board. See, those wires have been soldered quite a few times, and then somebody added a capacitor on the signal here. So let's just try and power it up before I spend more time on funky stuff. So I am inputting 1, 2, 3, 4 hertz input. Let's try and turn on the mains. And then I suppose all we have to do is dial. One, 2, 3, 4. Oh, it blinks like that. That is so cute. I don't know if you can see this, but there's definitely a contrast kind of problem here. This is gonna be better later tonight. Maybe if I do like this. But it says 1, 2, 3, 4. How nice. So I think it works. I've been poking around with this screw. There's just no way I can get it out. But I've actually figured out what was the cause of all this. I don't know if you can see this the thread here in that one, and let's compare it to the other side of this piece. I think this is of course a little unfair way to show this. Well, let's look. This is an M3, so this is the other side of the, oop, that one goes straight through. So that one is bigger than that. And in the back, this one looks a lot like M3, but it can only go in a little bit and then it kind of gets stuck. And then somebody with a little less brains just thought, hey, let's yank it in as hard as we could. And of course it's going to break, and now you have this kind of problem. The screw that really fits is this screw. And let's compare it to an M3. So it's actually an M2.8 or something like that. It is just a tiny bit smaller than M3. I don't know if that is possible to see. It's more or less the same kind of thread, but diameter is tiny, 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 little, almost invisible to see, smaller. And that screw fits perfectly fine. There must be a special place in hell for people who's doing stuff like that. No, I can't fix this in a nice and cool way. I have to put the press nut out and put in a new one. And then, I don't know, I'm not happy about that. This is actually needed because the stability of the case depends a lot if this is mounted or not. That screws. Otherwise the whole thing is going to go yabbity yabbity. I want it to be nice and stable. Well, meanwhile, I can tell you a little bit more about this nice unit. So it's from 1962, 1963. We got 87 transistors in here. And it's supposed to handle 300 kilohertz. And there is actually also a B model. This is the SA520, but there's also a 520B, and that one is a side-lit display. So instead of all those bulbs like this, then the bulbs are mounted, yeah, and then the plastic, and you know what I mean, side-lits, right? This acrylic with the drilled numbers and all that. So they're really, really nice. I love side-lits. Maybe I should make a little video of my side-lit counter as well. So the little plastic bag I found in the unit, that was that screw and the little nut, and it was also in this funky measurement size. And I also changed the two screws to M3 that's holding the connector, because they're just using 3 nuts. So now I got all the screws in the special thread that I need to assemble everything correctly. And here was the broken. I just figured out that you could fit in an M3, and that is now nice and stable. So I think I'm now able to assemble it more or less correctly. Yeah, okay. Except for that one, but that is not super important. It's just amazing that somebody took this two bits and pieces and threw away half of the screws. Let me remind you guys that please put all the screws in a little container or bag or something, and always keep it together with the unit. Look at that. It's not an original screw like that, right? Completely wrong size. Yeah, I think I'm done playing with this unit now. I'll just assemble it again. And there's not a lot more to say, and then I'll try and test for all the different speeds and stuff. Yeah, okay, about the DC power supply connector. 2 of the 4 pins, they're black, so that is chassis, that is ground, And then there's a positive and a negative supply. So you need two battery voltages to run this unit off an external supply. So now it's assembled again, and I want to test some more before I assemble it completely. And now the reading is much better with contrast here. I cleaned up everything. Of course, I'm gonna test a little bit. Aha, so that is the input clock frequency. I think that is correct, right? So let's see if it can go to the 300 kilohertz it was supposed to do. So this is yeah, hertz, 1 2 3 4 hertz, and let's try and give it 10 kilohertz. Then we can't see how much we got, right? Aha. So this is 10 kilohertz. So that one is of course 100 kilohertz. So how about we crank it up? 60. Ah, now that is actually a super good opportunity to test all the different digits. I'm of course not going to run through all of it, because it's going to be pretty boring to look at. But that was 100 kilohertz. So that is 200. That is 300. That is the specified 300. Oops, and then it goes 400. 399. 500. Yay. Let's see if we can do. No, we can not. That was 600. So that is 500, and it is definitely doing 500. How amazing. I actually did not expect that. So what if we're doing 4, 5, 6 kilohertz? Yes, exactly like that. Oh, so that's doing a little bit of flippity floppity. Ah, yeah, okay. I kind of love this instrument already. This is really nice. And then you get more and more of your digits like that. It will just overflow. And it's stable to the last digit. Yeah, exactly it is. So this one is hertz, 1 hertz, right? Okay, so that is 4, 5, 6, and then 7, 8, and then 9. Let's see if it's showing that. 6, 7, 8, 9 should have been the correct. So of course there's a trimmer here on the side, but I want to see. Okay, it's only using 13, 14 watts, so I don't expect this to be warm or anything, but I could just tune it. How about we do that? Look what I did. So there's a trimmer capacitor right next to the crystal. It's actually the top left one here. And 6, 7, 8, 9 is the correct. So it's doing this more or less all the time. Yeah, plus minus 1 hertz. That is nice that is possible. 5, 6, 7, 8. Oops. Yeah, here we go. Thank you. Must do this right. And you can see the refresh, or the blink, is actually changing, right? So here it's counting for a shorter period of time and then displaying for longer. So when it's counting, it's just blanking the displays, because there isn't any latches or anything counter, and that is definitely why it's doing this. Just turn off power to the bulbs, otherwise you're gonna see bliggity blah blah, and then it's gonna stay stable. So that is exactly what they're doing in this counter. And that's actually not such a dumb idea. It definitely works.